All right, so now for the second part of our lesson, we're going to be solving equations. So not just simplifying expressions, but actually solving for x. So problem 5 asks you to solve an exponential equation of 5 raised to quantity 3x minus 3 times 5 raised to 3x equals 1 divided by 625. So what makes this an equation is that there's an equal sign and a left side and a right side. What makes this an exponential equation is that the unknown value, the variable x, is in the exponent. So this is a little bit different from what we're used to seeing in earlier classes. And then remember, there are many ways to solve exponential equations. You'll learn about them in Algebra 2. The one way we know so far is to use properties of exponents. So in order to do that, the equation has to be in this particular form, which is base raised to a power equals base raised to a power. So I wrote a raised to m equals a raised to n. So somehow we have to rewrite things so that the equation is in this exact form. So I'm going to start just by rewriting the problem. 5 raised to quantity 3x minus 3 times 5 raised to 3x equals 1/625. I'm going to take a note that the bases are not the same. I have a base of 5, a base of 5, and a base of 1/625. I'm going to try to write 5 and 1/625 as numbers with base 5. I'm going to remember that 625 is 5 times 5 times 5 times 5, or 5 to the 4th. So 5 raised to 3x minus 3 and 5 raised to 3x stay the same because they are already base 5, but 1 divided by 625 becomes 5 raised to negative 4th. Negative 4th because it's a fraction. If it was just 625, it would be positive 4th. So now I have two different bases raised to powers on the left side, and there only needs to be one. So I'm going to rewrite the left side by using rule 5, which says if you multiply powers with the same base, you add the exponents. So the exponents in this case are 3x minus 3 and 3x, so I'm going to add them, and I'm going to keep the base 5. So on the left side, I'm going to have 5 raised to 3x minus 3 plus 3x equals to 5 raised to negative 4th. And then I'm going to simplify. I'm just going to add the terms in the exponent. So 5 raised to 6x minus 3 equals 5 raised to negative 4. Okay, now I have the same basis. So what I can do is just equate exponents. If the bases are the same, the exponents must be the same too. So 6x minus 3 equals negative 4. And now you just have a two-step linear equation, which you know how to solve. I'm going to add 3 to each side of the equation. You'll get 6x equals negative 1. And you're going to divide each side of the equation by 6 to get x equals negative 1/6. And that is it. We're just going to state our result at the end. The solution is x equals a negative 1/6. Problem 6, you're asked to solve another exponential equation. So you will be solving for x, not simplifying, but actually solving for x. These equations are called exponential equations because the unknown value, variable x, is in the exponent. Recall that to solve exponential equations, they have to be in the form a raised to m equals a raised to n. So we have to rewrite them in that form first. We're going to begin just by rewriting the problem that was given. 32 raised to 2x plus 2 equals 4 raised to 3x. We're going to note, as we always do at the beginning, that the bases are not the same. The base on the left side is 32. The base on the right side is 4. So we cannot let 2x plus 2 equal 3x just yet. We're going to have to rewrite 32 and 4 as numbers with the same base. 32 is not a power of 4. There's nothing you can raise 4 to get it to equal to 32. But 32 and 4 are both powers of 2. So we're going to rewrite 32 and 4 as numbers with base 2. Remember that 32 is 2 times 2 times 2 times 2 times 2, or 2 to the 5th, and 4 equals 2 times 2, or 2 squared. So 32 becomes 2 to the 5th, and 4 becomes 2 squared. Note that I put parentheses around 2 to the 5th and 2 squared. I did that so I can keep track of what happens with the exponents that were already there. Now what you have is a power raised to a power on the left side and on the right side. we're going to apply Rule 6. Rule 6 says if you raise a power to a power, you multiply exponents. So on the left side, you get a 2 raised to 5 times the whole expression, 2x plus 2. And on the right, you have 2 raised to 2 times 3x. And then we're going to simplify. So on the left side, you get 2 raised to 10x plus 10. And on the right side, you get 2 raised to 6x. Now we're going to know that the bases are the same. You get base 2 on the left side, base 2 on the right side. So now we can equate the exponents. 10x plus 10 equals 6x. Now you have a two-step equation, a two-step linear equation, and you know how to solve those. We're going to begin by subtracting 6x from each side, so you get 4x plus 10 equals 0. Then subtract 10 from each side. This will give you 4x equals negative 10. And then we're going to divide each side by 4 and reduce. So x equals negative 10 fourths, which equals negative 5 halves. And then finally, we're just going to state our result. So the solution is x equals negative 5 halves. Okay, moving on to problem 7, we're asked again to solve an exponential equation. 1 divided by 3 raised to 2x times 27 raised to quantity 2x plus 5 equals 81 raised to x. Again, this is called an exponential equation because the unknown value, the variable x, is in the exponent. We're going to begin by rewriting the problem that was given. 1 divided by 3 raised to 2x times 27 raised to 2x plus 5 equals 81 raised to x. The first thing I'm going to do is try to get that 3 raised to 2x out of the denominator. I'm going to apply Rule 2. Rule 2 says 1 divided by a to the m is the same as a to the negative m. So I'm going to bring that 3 to the numerator, but then the exponent is going to become negative. So 1 over 3 to the 2x becomes 3 raised to negative 2x. All the other terms stay the same. Note now that the bases are not the same. You have a base of 3, a base of 27, and a base of 81. So I'm going to rewrite 3, 27, and 81 as numbers with base 3. Remember that 27 is 3 times 3 times 3, and 81 is 3 times 3 times 3 times 3, or 3 to the fourths. So 3 to the negative 2x stays as 3 to the negative 2x. 27 becomes 3 cubed. So you get 3 cubed, in parentheses, the whole thing raised to the quantity 2x plus 5. And then 81 becomes 3 to the fourths. So you get 3 to the fourth, in parentheses, raised to x. So now you have powers raised to powers. And we're going to apply Rule 6. Rule 6 says if you raise a power to a power, you multiply exponents. So we're going to get 3 raised to negative 2x, that term doesn't change, times 3 raised to 3 times the whole quantity 2x plus 5 equals 3 raised to 4x. Then we're going to simplify. We're going to distribute that 3. So we're going to get 3 raised to negative 2x times 3 raised to 6x plus 15 equals 3 raised to 4x. And then we're going to apply Rule 5 to the left side of the equation. When you multiply powers with the same base, you keep the base and you add the exponents. So 3 raised to negative 2x times 3 raised to 6x plus 15 equals 3 raised to quantity negative 2x plus 6x plus 15. Notice the base stayed as 3, did not become 9. Okay, we're just going to simplify, add the like terms in the exponent. You get 3 raised to the quantity 4x plus 15 equals 3 raised to the 4x. Now we have the same bases on the left side and the right side. You have a base of 3. So you can equate the exponents. You can write 4x plus 15 equals 4x. Subtract 4x from each side, you get 15 equals 0. And of course, we know this is a special case of a linear equation, when the variables fall out and you're just left with a number statement. We just have to say if this is always true or always false. Now, in this case, obviously 15 is never equal to 0, so this is always false, which means our equation does not have any solutions. So we did all this work just to conclude that there are no values of x that can make this equation true. We're going to state our results. There are no solutions. We have come to the end of the lesson. Now you're ready to try some of these problems on your own. You're ready to work on a problem set for this lesson. The problem set is due for B-Day classes on March 19th by 10 a.m. and for A-Day classes on March 20th by 10 a.m. I am available from 9 a.m. to 4 p.m. for questions. Either email me or contact me through Schoology. And the way we're going to submit the assignments is either a photo or a scan of your work, or if you did it in Notability, just the PDF file of your work through email or through Schoology.